already. Right, what I wouldn't mind, folks, is if, let's stay in the shade here. I want two lines about 1 meter apart, facing each other in pairs. Clement, can I have you up front here, please? Thank you. You don't mind me sticking. And Tanya, can I have you up front here, please?
Oh, sorry. See you, Tony.
So the folks like that,
When I drove in up those hills here.
are we not close now? Well, I'll tell you what, I'm going to need a cup, so I'm going to finish that off you.
What did we?
Right, what I want you to think about, is how does water move through soil?
What's this?
How does water move through soil? Okay, and we've got two soil profiles here, and each of you represents 6 inches of that profile. So top 6 inches, the next 6 inches, working our way down until you get to the bottom here, where you're starting to get to that deep soil and deep soil moisture. Okay, so how does water move through the soil to get down there to the springs? How does it do it? Air spaces, so it might move through air spaces. Yep. How else? Okay. Capillary action sideways. So if you pour a cup of water into a sand pit, does it keep moving sideways? Does it keep moving down? The gravity is still constant.
Always.
What is that, layers sort of?
It filters.
What keeps it going?
Gravity.
Gravity is constant. You pour water in a sand pit, it goes so far and doesn't go any further.
High concentration to low concentration.
Okay, so salts would do it, yeah? Okay. What keeps water moving through the profile?
If you keep on adding water.
Keep adding water.
Yeah.
It's the weight of the water on top that pushes the water below. Okay? So yes, it will run down cracks, yes, it will run through root hairs, etc., etc. But ultimately, most soil moisture, you know, if you take a soil sample in to have it analysed, they've got to put it in an oven to bake it to get rid of that moisture. That's how tightly it hangs on to the soil particles. So it hangs on really tightly. To get it to move down, you've got to add more water. Okay? So what we're going to look at is how does that move through the soil profile. So we've got two soil profiles here, 6 inches for each of you. Okay? And I'm going to suggest you all get this cup with a hole in, which represents field capacity for your soil. Okay? So, at the beginning of the week, we have an inch of rain, which is going to fill you up to capacity. We have that same inch of rain on this soil, which fills you up to capacity. Okay? Now we have two very different soil surfaces. This soil surface here is completely covered with litter and nice stuff, no evaporation. This soil over here needs a lot to be desired, okay? Lots of evaporation. Now science is saying that could be as high as 93%. That makes the maths really difficult. So we're just going to say 50%. So we're going to have a week of sunlight, and I'm going to ask you to give me back, just mind the hole there, give me back 50% of that rainfall. Just don't go to his pub. That's about right, that'll do. Okay, so we have a week of sunshine, we lose 50% of the moisture from you. From here we don't lose anything because we've got this lovely little layer on here. So after a week, this is Magic Farm, we then get another inch of rain. So it pushes the water from this profile, yep, and then pushes it down into that next profile. We have the same inch of rain on this profile. It tops up there and then pushes it down into the next 6 inches of the soil. We then have a week of sunshine. From this soil we lose nothing because it's got full cover. From this soil I want 50%, please. Now through that capillary action, you want fully saturated, so you're going to draw up from deeper down. So top him up to the full mark. You can't hold your drink, huh?
No.
Magic Farm, a week later we have another inch of rain. Okay, it goes to this profile. Sam, bring your cup up, tops it up, and then pushes deeper and deeper and deeper down into the soil moisture.
Right into the bathroom.
Same profile, we get an inch of rain. It fills up that profile and starts pouring into the next profile. And then you know the trick. We have another week of sunshine. From this soil we lose nothing. From this soil we lose half. It's getting repetitive, isn't it?
You're like the ATO.
It's never ending. Okay, a week later we have the inch of rain. It tops up that profile and it starts pushing the water lower and lower. And
Where's your, you got to be under
No,
there.
you're in the
you got to be in there as well.
Yeah, you've got to be in there. Where is his hole?
I think you have to then cut it or
Where's your hole?
He's got his finger over it, has he?
Sounds like a mining company.
It should be, mine's up to here.
So folks, that's the way it works. And as we keep on adding water, suddenly this one, we're starting to fill bores, springs are flowing stronger, rivers and creeks are flowing for longer. Whereas your bucket is empty, dear Liza, you know, and suddenly one day the borehole's just coughing air. Okay. So it's about keeping that soil cover. It has this huge impact right the way down to the aquifer. Okay. Now let's think about salt. Okay, because the old idea was we plant trees, drain away the water, and the salt layer drops back. Okay, so that research, fortunately, there's more research coming out that's a little bit better than that. Okay, water coming from the sky in terms of rain, virtually 100% water. Put a nice little bit of this up to that. Okay, it falls on the soil, and as it moves through the soil profile, it dissolves and picks up those salts. Okay, so in this, which is heavier, salt water or fresh water? Fresh water. Salt water, much more dense, so it's heavier. So where would the salt layer be here? It would be down here somewhere, way out of the plants, way out of everything. Where would the salt layer be here? As it goes to the soil, it's going to dissolve salts. As it evaporates, what does evaporate as? Pure water. So all your salts get left right here. Because there's soil, it will tend to move to those lower areas, and suddenly we have huge salt problems. So research is now showing that. Okay, and the strength with which salt and fresh water stay apart. I had two really good examples. The first guy was a guy who sailed a yacht around the world. Anybody sailed a yacht around the world? Panama Canal, anybody? So you go in on one side, he went in on the Mexican side. You lock up. A big freshwater lake in the middle of Panama, and then you lock down the other side. And he said it was quite a funny story because you're in this lock with this huge container ship, and you've got about 12 little yachties all tucked in around this container ship. And you get down to the last lock, and they pump the water out, so you're now level with the ocean. And the stevedores were running up and down the wharf selling extra ropes and tires to all the yachties. But he couldn't speak Spanish, so he didn't. But he saw all the other yachties were taking these tires and lashing their boats more with more rope and more tires. That he did the same. And he said he was right in front. So when they actually opened the gate, here was the water in the lock, and here was the Pacific Ocean, just beautiful flat. And he said the next thing, the container ship didn't move, but the little yachts on either side were being thrown around, ropes were snapping, tires were shredding, and all that was happening was the salt water was moving in to get underneath the fresh water, and it created this huge agitation. It's like being in the washing machine. And this is why everybody was buying extra ropes and lashing down. So it's very active the way salt sticks under fresh. The other experience I had was a submariner, and he was talking about when you're going along coastlines in a submarine. So you get all your ballast and your trim and blah 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 all right, and you're travelling along and you suddenly hit almost like a wall, you hit fresh water because there's a stream or something. And either you go charging up to the top or you go plummeting down to the bottom, and everybody quickly rushes around, does all the adjustments and changes the ballast and whatever. But again, it's how definitive that line is between salt and fresh. And fresh water will always stay on top of the salt. So if we want to get rid of the salt issue, it's about covering soil. So if we can just get cover soil and keep this process going, where we drive those salts back down there where they should be, rather than this process which is constantly bringing up and putting them right on the soil surface where they then get moved. And again, it doesn't matter whether you've got trees or not. There can be salinity problems. Okay, it's about that soil surface. That's where transpiration might be 15 to 24%, even in the forest. It's that soil surface evaporation we've really got to take care of. Okay. Any thoughts, any questions about this? Now that raindrop's got to go in the soil and stay there and be protected by a literal mulch. Folks, let's just dart across there quickly.